So we're starting the next unit, which is Unit 4, and it's all about the Puzzle Cube Design Challenge. So it's the project that we've been kind of waiting to start. If you go into Project 4.1, kind of farther down in the activity itself is this design brief. And the design brief is kind of like a one-page summary of everything we need to know for this project. So I wanted to kind of go over this first before starting the activity for today. So on the design brief, we have our client, we have the target consumer, the designer in this case would be you, because you'll each come up with your own design. It has a problem statement. It says that a local office furniture manufacturing company throws away tens of thousands of scrap 3/4-inch hardwood cubes that results from its furniture construction. The material is expensive and the scrap represents a sizable loss of profit. And so the idea is the office furniture company would like to retain some value, return some value from its waste product from this raw material by making some sort of novelty item that would go on the desktop. And so they want you to take these cubes and make basically a puzzle out of using these cubes. This is the most important thing for our design brief, which is our criteria when we start thinking about the design of what this puzzle cube is going to look like. The puzzle must be fabricated from 27 3/4-inch hardwood cubes. That's what I purchased, 3/4-inch wood cubes, so you're good for there. Puzzle system must contain exactly 5 puzzle parts. Okay, so there are 5 individual parts made from those 27 cubes that will come together to make one larger cube. Each individual puzzle part must consist of at least 4, but no more than 6 hardwood cubes that are permanently attached. So we're going to glue them together. So between 4, but no more than 6. Okay, so it could be 5, it could be 4, somewhere in that range. No puzzle parts can be the same, so you can't have identical pieces. 5 puzzle parts must assemble to make a 2 1/4-inch cube. Some puzzle parts should interlock. Interlocking simply means that there's some sort of connection between them. Doesn't necessarily mean that they're going to hold them together. But when you design pieces that are kind of just flat on top of each other, it's overly simple and easy to solve. So pieces that interlock with each other make it a little bit more challenging. 7, we're going to kind of disregard. Some people are really good at solving puzzles. Some people are really bad. Like I am not so great at solving these puzzle cubes. I think I just get frustrated too easily. And so to put a time limit on how long it would take to solve is kind of difficult. So that's kind of what we're going with. That's the deliverable for this unit is this project. And so let's look at the actual starting point, which will be 4.1a puzzle part combinations. The goal for this is to come up with as many possible solutions of different puzzle pieces that we could design using first 3 cubes, then if we used 4 cubes, if we used 5, or if we used 6 cubes. Okay. So if we started with just 3 cubes, how many possible solutions can we come up with? Well, there's really only 2. I've blown this up just so you can see it, but when you draw it, I would just do kind of 1-to-1. One of these cubes is 1 square on your isopaper. So I have 3 in a row like this, and I have like my L-shaped piece, right? Those are the only possible combinations I can come up with using the 3 cubes. Keep in mind that if I draw it in a different orientation, like if I were to flip it and draw it differently, that's not a different piece, it's just been rotated. Right? So when we're talking about unique pieces, in this case, there's only going to be 2. If I were to add 1 more cube to this, so instead of using 3, I'm using 4 cubes, how many possible solutions could I come up with? Okay. So for 4 of the cubes, there are 7 possible designs I can come up with. So I want you to come up with what those 7 are. I add another cube using 5 cubes. How many designs can I come up with? There's quite a few, right? So let's just go with 10. Let's come up with 10 ideas using 5. And 10 ideas using 6 cubes. Each of these should fit pretty much on 1 sheet of isopaper, especially if you go 1-to-1 for your cubes to this. Draw it like I did, where it's a solid piece, not individual cubes. Right? So I treated this, even though it's made up of 3 actual plastic cubes, I'm drawing it as 1 solid piece. And do the same for each of these. And do add the tonal shading on this. So my design's using 3 cubes. I already have the answers here. And I'll do the designs using 4, using 5, and using 6 cubes. At the end of the activity, there are also conclusion questions. There's 3 questions. So on top of completing the isometric sheet, do answer the conclusion questions. It can be in your notebook or it can go right on this Word document, and both of those will be submitted onto the LMS.